Randomly, I have taken some questions and some questions were asked by you. So, uh, okay, fine, let us start now. So, yeah, I think this question by asked by some of you in the previous classes. So, this was given in GATE 1998 and ACE. This is from digital electronics. So this is kind of a latch, right? If you see this, this is a NAND latch. So the question is in figure shown below, A equal to 1 and B equal to 1. The input B is now replaced by a sequence 10, 10, 10. The output X and Y will be. So initially A equal to 1 and B equal to 1 they have given. Okay. Now what is given is after that the input B is now replaced by sequence. Instead of 1, they have replaced with the sequence 10, 10, 10 like this. Then the outputs X and Y will be they're asking. So different options they have given fixed at 0 and 1 respectively, like that. 4 different options are there. Actually, for this, if you want to get one, if we want to select one option from the given ones, something needs to be given. Which gate responds faster? Two gates are there, right? So, which gates responds faster? That need to be given. You might have studied about propagation delay of a gate. This you might have studied, right? Propagation delay of a logic gate. Okay. That means some gate is there. Suppose some input you are giving, some output you are getting. Okay. Let us say input is changing from low to high or high to low, something like that. So then output, let us say, has to change from high to low, let us say. So that transition will not take place immediately. It will be done after some time. Let us say the input X is the input, let us say, changing here. Okay, then the output immediately will not change. Let us say it's a NOT gate, for example. Input is changing from low to high, then output should change from high to low, right? For NOT gate inverter, output will change from high to low. Okay, but not immediately, after some time. So there is this time gap. This time delay is nothing but the propagation delay of a gate. This will be generally in nanoseconds. Okay. Now let us see here for first gate. Let us say this is gate 1 and this is gate 2. For first NAND gate, the propagation delay is low. That means NAND gate 1 responds faster compared to other gate. NAND gate 1 responds faster compared to NAND gate 2. That is the assumption. So what will happen now? Since NAND gate 1 responds faster, now there is a feedback. First we will calculate the NAND gate 1 output. There is a feedback here. So Y is going here. So for this NAND gate, what is the output? 1 NAND Y whole bar. 1 and Y is 1 only, whole bar is 0. This is 0. So X is 0, output is 0. Okay. Now after that, let one first gate responds, then only the second gate responds, right? First gate propagation delay 5 nanoseconds. Let us say second gate propagation delay 10 nanoseconds, assume. So now for the second gate now response, so one input is 1, b is 1, right? Initially they have given, and another input is 0, x, right? X is 0 now. This one, there is a feedback, right? So the output is what? 1 and 0 whole complement. So this is nothing but 1. So output equal to 1. Okay, what they're telling, instead of 1, they are replacing with this sequence. Okay, that means let us say now we are giving 1 at B. A you are fixing, and now B 1 you have given. Now same thing happens, right? B is 1, right? Now B1 immediately who will respond? Immediately the first gate only responds. Anyway, output of first gate is 0. It maintains same at the 0 only, because y is already 1 here. Y is 1. 1 and 1 whole complement is what? 0. Now x is 0. This input is 1. No change, right? 0, 1 whole complement 1 only. Y is at 1 only. That means y is at 1. X is at 0 only. Now next 0 you have given. Next is 0. That means here I am giving 0. Okay. Now 0 is given. Now what will happen when you are giving 0? Anyway, for the second gate, now for the first gate there will not be any change, because already 1 is here, A is already 1 is here, and Y is 1. So first gate now it will not change. Now only for the second gate 0 we have given, right? 0 and 0 whole complement is what? 0 and 0 whole complement is 1. So again it is 1 only. Now it's 1 goes here. That means there is no change, right? Next you are giving 1. Instead of 0 you are giving 1. Now 0, 1 whole complement is 1 only. So on this sequence, how many times you give, what will happen? X remains at 0 only, Y remains at 1 only. Okay, that means X is fixed at 0 and Y is fixed at 1 respectively. First option is correct. Understood? If gate 1 is 1 responds faster than gate 2. Have you understood this? Is that okay? Fine. Now they have not given which gate is faster, right? So other assumption also there. Gate 2, let us say assume gate 2 is faster compared to gate 1. Gate 2 is faster compared to gate 1. So just opposite to the previous one. There is a feedback. This is X, this is Y, this is A. Initially A equal to 1 they have given. B equal to 1 they have given. Gate 1, gate 2. Assume gate 2 is faster compared to gate 1. When gate 2 is faster, what will happen? First gate 2 will respond. Now for gate 2, what are the inputs now? X and 1. NAND gate 1 x whole complement, that is 1 complement, that is 0. Y is at 0. And this Y is at 0. Y is going as feedback here. Now A is another input. So 1 dot 0 whole bar, it is 0 bar, that is 1. X equal to 1. Now instead of B, you are replacing 1 0 1 0 1 0. Same thing will happen now. You are giving 1 here. Since gate 2 is faster, you are giving 1 here. What will happen? Already 1, same thing will not change. Next is 0 we are giving. Now 0. X is already 1. This 1 is coming here feedback. X is 1. 1 dot 0 whole complement. sorry, 1 dot 0 whole complement. Now what will happen? 1 dot 0 whole complement is 0 complement, that is 1, right? Am I correct? So 1 is here, 0 is here, 1 dot 0 whole complement, that is 1, sorry, 0, right? Or 1, 1, sorry, 1. Now this 1 is going here, feedback, 1 dot 1 whole complement, 1 dot 1 whole complement, that is 0. Now 0 is going here. Okay. Next 1 is coming. The same. Now 1 is coming. 0 is here. Feedback 0 is coming here, right? Next is 1 is coming. Now what will happen? 0 dot 1 whole bar. It is 1 only. That means 1 will be here. Here 0 only. Next 0 is coming. 0 dot 0 whole complement. So 1. So output is 1. 0 only. That means same thing is happening. X equal to 0 fixed, y equal to 1 fixed. Okay, you got it right? Is that okay? See, assume initially gate 2 is faster. Here it assume gate 2 is faster compared to gate 1. So what will happen? Initial output will be, let us say when a equal to 1, b equal to 1 you are giving, initial output will be this one. X is 1 and y is 0. X is 1 and y is 0, initial output. Then what will happen? You are changing with this. Now when x is 1, y is 0, that means you have 1 here. Next let us say this 0 coming here. 1 dot 0 whole complement is 1, right? That means y became 1. Now this 1 is going here. 1 dot 1 whole complement 0, x became 0. Next 1 is coming, that means this 0 is coming here. Now 0 is here. Next 1 is coming. Since one input is 0, right, for this NAND gate one input is 0, irrespective of other input 1 or 0, the output remains at 1 only. 1 1 1 1 1 like that only. Since it is 1, a is anyway 1, this 1 is going here. So 1 dot 1 whole complement is 0 always, 0 0 0 0 0. So x is at 0, y equal to 1. So in the first case what we have seen, if gate 1 is faster, if gate 1 is faster, okay, first x is 0 we have, y is 1 we have, but when you replace with the sequence 1 0 1 0 1 0, x 0 0 0 0 0 only continuing, y 1 1 1 1 1 only continuing. Or else in this case what we have seen, if gate 2 is faster, initially what? Initially x is 1, y is 0, but when we are giving that series 1 0 1 0 1 0, that series, x 0 it became first time, y 1 it became, after that 0 0 0 0 0 is it's coming, 1 1 1 1 it's coming. In both the cases if you see, x is at 0 fixed and y is at 1 fixed. So answer option 1 is correct. Okay, ma, is that okay? Understood? Fine. We will move on to the next question. Yeah. So this was given in GATE 2022 ECE for 2 marks. 1 x bar is 1 where written 0, right? 1 x bar 0, right? 1 bar 0 only we have written. 1 x bar 1 bar 0 only we have written. Can I unmute and tell where we have written? 1 x bar nowhere we have written, I guess. Okay. 1 x bar 1 into anything, so 1 and anything is 1, whole complement is 0. For NAND gate, you know, right? One of the inputs is 1, output is 0. Now, this is the circuit. This was given in GATE 2022. The consider is a circuit shown with an op amp, ideal op amp. Okay. The output voltage V0 is dash. If you observe, can somebody tell me this is which circuit? This is from D to A converters, digital to analog converter. Okay. And that too, this is which circuit? And that many are there, DTA converters, flash converter, R to R ladder converter, and something else is there. What is this? This is R to R ladder DAC, right? Isn't it? If you see this, this is R to R ladder digital to analog converter. Okay. If you see here, generally you might have seen this. This is like you will have some reference voltage here. Okay. Sorry, not ground. You will have some reference voltage here. Some voltage, something is there. Now you will have some switches here. Some switch, some switch, some switch, some switch. Okay. Now, actually, if you see here, uh, the switch that is closer to the operational amplifier is nothing but the MSB, most significant bit. Let us say this, I will say MSB, and the switch that is away from the this one is called LSB. And there is an extra 2R here. This anyway should be grounded. That extra 2R should be grounded. Okay, that is the actual operation. That is the structure of R to R ladder DAC. Okay, this 2R is extra one. Okay, other than that, you see how many are there. So this is MSB, near to that. The last one is LSB. So this one is, let us say, A naught or D naught. This is D1. This is D2. This is D3. Okay. So the last one, grounded one, you leave it. From there onwards, you see D0, D1, D2, and D3. Okay. So this is 4 bit. How many bits are there? D0, D2, D1, D2, D3. This is actually a 4-bit DAC. 4-bit digital to analog converter. Okay. Now, so what it does actually, digital analog converter. This is a DAC. Let us say you will give inputs bits some d1, sorry, d0, d21, d2, d3. You will get analog output based on what is the step size something. You will get analog output. So suppose if I am giving 1010, okay, and if the step size is 0.5 volts, let us say, then what will be the output? What is the decimal equivalent of this? We will calculate. Decimal equivalent of this is 5. 5 into step size 0.5. Output is 2.5 volts. Okay, na? This is about DAC, right? What is the step size? Only give the LSB as 1 and remaining all zeros. Then you find out the output. That is nothing but the resolution or step size, right? So resolution is 0.5 here. Okay. So a DAC converts digital input to some analog output. This is one kind of DAC, that is nothing but R2R ladder DAC. This is the arrangement. Why it is called R2R? If you see here, there is an R here, there is a 2R here. And again there is an R here, there is a 2R here. Again there is a R here, 2R here. Okay. There is a 2R here. This R you can say, 2R you can say R plus R. Okay. So how many those kinds of there? 1, 2, 3, 4. That's why it's a 4-bit DAC. Okay. And practically how the circuit is, you have switches here. Let us say VR equal to 1.6 volts. Based on the digital input, if my digital input D3, D2, D1, D0 is, let us say, 1001, then what to do? D3 should be connected to 1.6. D3 should be connected to 1.6. That means D3 should be connected to this switch, should be closed. Okay. And D0 is 0. So D2 is 0. So D2 is 0 means this should be connected to ground. And D1 also ground. And D0 is connected to 1.6 volts. Hope you understood. Okay. These two switches we don't connect. So D0 should be 1, 1.6, and D3 should be 1, 1.6. You need to connect like that. Okay. So based on that, you will get the output. In this case, if you see here, in this case, have you understood, right? Okay. I'm just giving the brief background of it. Based on that, we can see. Okay. In this case, actually, if you see here in this DAC, so D3, D2, D1, D0 is what? MSB is what? 0 they have given, because MSB is connected to ground. This is D3 and this is D2. D2 is 1 they have given. Okay. And this is D1. D1 is connected to ground. 0 they have given. And this is LSB. D0 is 1. That is connected to VR. So this is something like this. Okay. You got it? So this one LSB and then D2 and D0 are connected to the reference voltage, and D1 and D3 are connected to ground. Okay. In general, what will be the output we will see. Based on that, we will find out for this. Okay. We can quickly calculate, but I'll just go through some background how to calculate this. Have you understood about the circuit and my others? If you have understood, then we will go ahead. Fine. So now what I will do, I'll try to find out the output. Right, op amp is, when it is operating in linear region, it is a linear circuit, and all resistors are linear elements. So the entire circuit is linear circuit. I can use superposition theorem. Okay, I can use superposition theorem. One source at a time, like that, to find the output. Okay. Now what I will do first. First, I will consider the LSB connected to VR and all other grounds. I will do like that. Okay. So this is my LSB D3, D2, D1, D0. Okay. First, what I'll do, I'll only consider D naught is connected to VR reference voltage and all other are connected to ground. Okay, D2 also connected to ground. Now, if you see here, this is an inverting amplifier. Can you see that this is an inverting amplifier? Fine. This is some kind of R to R ladder. Now, what I will do till here, this circuit I will take. I'll find out the Thevenin's equivalent. Thevenin's equivalent, that is VTH and RTH. I'll find out and I'll replace the entire circuit with like this VTH and RTH. You know this, right? Okay. So hope you understood this. How to solve this? I'm just telling, but no need to solve in the exam. But so this is our VR connected to VR, and from here this is 2R, this is R, again this is 2R connected to ground, R, again this is 2R, this is R, and up to here this is connected to ground, this is connected to ground. Now looking from here, I want to find out VTH and RTH. Okay. Now here what is connected here? Here VTH is VR is connected. Some VR. Now for this, can I replace like this? Only this one. Can I replace this with this? For this Thevenin's equivalent is what? VR by 2. And this R and R parallel. Before calculating the entire one, for only this one, can I do like this? Yes or no? Only this part I am writing. So that part is what? 2R, 2R, VR. This is 2R, 2R. This is VR. From here, looking from here, VTH and RTH, I can find out. What is RTH? You just short it, right? If you VR, if you short it, that is RTH, right? So that is 2R by 2. Both are in parallel. That is R is the RTH. Now what is VTH? Can I write like this? The same one I can redraw like this. VR 2R R. Now from here voltage is same as that one. What is the voltage now? Voltage division principle you can apply. VTH equal to VR into 2R by 2R plus 2R. So VR by 2. So that means this part I can replace with like this VR by 2 and R. This part I can replace like this. Do you agree? Okay. Now, okay, repeat. Only this part you take. For simplify, how to simplify, I'm telling. Only this part you take. That I will replace with equivalent circuit. That's it. Okay, na? The same thing. Equivalent circuit means what? 2R is here. VR is here. Looking from these terminals, its equivalent I want to find out. So how to replace with its equivalents? In general we use Thevenin's. VTH and RTH I can replace. Now what I am doing here, this circuit just I am rewriting like this. Since these are all connected right to ground, you can see all are connected to ground. Okay. Now can I redraw that circuit like this? VR, 2R and 2R. Can I rewrite? Just they're parallel, right? Just I'm changing. That's it. Now, looking from here, what is VTH? What is the open circuit voltage looking from VTH here? What is VTH? This still I can redraw like this. This one still I can something like this. Can I redraw like this? 2R. Now, what is VTH now? You can use voltage division principle, right? The entire voltage VR is divided between these two resistances. Our VTH is nothing but voltage across 2R. So this is VR by 2, right? The voltage VR is divided between two resistors, VR by 2. Okay. Now to find Thevenin's resistance, how to do, you know, right? From this, how to find out the Thevenin's resistance? Resistance seen from here when all the other sources are deactivated. That means the voltage sources are short circuited and current sources are open circuited. That is nothing but the RTH, right? If you see here, this is 2R, this is 2R. Now both are parallel, right? What is RTH? 2R parallel 2R, that is R. That means this entire circuit can I replace with a VTH, that is VR by 2, and RTH, that is R. Hope this is fine. Now what I am doing is I am replacing this one with that one. So this part I am replacing with that. That means VR by 2 and R. Okay. Is that okay now? Till now? Fine. Now I together it will become 2R. This R and R they are in series. So this is 2R. Okay. Again this the same procedure I can apply. Till now whatever I've done, the same VTH RTH concept I can apply. Then what it will become? Instead of this, I'll get same way I'll get VTH. Now it will become VR by 4. Earlier VR was there. After that VTH is VR by 2. Now VR by 2 is there. It will become VR by 4. So this is R. Is that okay? Fine. Now instead of enter this one, I can replace again VR by 4 and R. That means I am arranging this. Same now I am replacing with R VR by 4. Okay. Now next time what will happen? VR by 8 it will become. Next is VR by 8 it will become. Next is VR by 16 it will become. Do you agree? How many ladders are there based on that? First ladder VR by 2, second ladder VR by 4, third ladder VR by 8, fourth ladder VR by 16. Got it? That means this entire circuit I will replace with what? I can replace this entire circuit with VR by 16 and a R. Okay, based on number of If one more ladder is there, VR by 32, it will become one more ladder is there, VR by 64. Is that okay? Fine. So what I am doing here, just instead of this entire one, I replaced with the Thevenin's equivalent. So I'm drawing here. Now I have this op amp circuit here. Okay. And feedback there is 3R. It is an inverting amplifier. Here is the output. Okay. Now here R is there. This is the actual circuit. Now I am replacing with its Thevenin's equivalent. What is the Thevenin's equivalent I got? R VR by 16. Okay. Sorry. Here 2R is there. Here 2R is there. Yes. Now this 2R and R together 3R. For an inverting operational amplifier, you know the output is, since op amp is ideal, they have given output is what? Minus RF by R1 into Vin, right? Hopefully you know this. So what is the output? Output is minus 3R by 3R into Vin is VR by 16. That means minus VR by 16. Okay, that is for the LSB. This is called step size. Only you consider LSB, remaining all bits you make 0, then that is called resolution of step size. This is step size. In our case, what is the step size then? If they ask step size, VR is what? 1.6, right? 1.6 by 16.1 is the step size. We don't keep negative since it's in an inverting amplifier, that's why it's giving negative voltage. Step size is 0.1. Okay, this is due to bit 1. Suppose if we give bit 2, what will happen? Suppose in whatever derivation I did, we have taken only bit LSB and remaining all I have not considered. Quickly I'll explain. You try to focus here. Now what I will do, all bits I will give 0. This also I'll give 0. So D not 0. So D1 I'll connect to VR. Next LSB. This is also 0 and this is also 0. So D2, D3 are zeros. Now what will happen if you see, okay, now if you see here, these two are parallel. Can you see? Again the same procedure I have to follow. I have to replace with entire circuit with its Thevenin's equivalent. Okay. Since D0 is 0, the first part is connected to ground. So this 2R and R are parallel, right? See, 2R and R parallel. Okay. So its equivalent resistance is R. Okay. See here, 2R and R are parallel. Its equivalent resistance is R. So this R plus R together, what will happen? They will be in series, 2R again. Understood? I don't know if you are able to understand or not. For this circuit, Thevenin equivalent, I want to D1 is connected to VR, R, this is 2R, 2R, this is connected to ground, 2R, R. Okay, now this 2R, 2R are parallel, so it will become R. So if you replace with that equivalent, it will become R. then this R series, then it will become 2R. R series, then it will become 2R. Now, can I follow the same one earlier, whatever I did? Thevenin's equivalent. Now, for this ladder, you apply the Thevenin's equivalent, you will get VR by 2 and R you will get, right? Again, this you replace with VR by 2 and R like this. Then one more ladder, VR by 4 you will get. One more ladder you can type VR by 8 you will get. Okay, VR by 8. Now what you will get? VR by 8 into R you will get for bit D1. So what will be the output in that case? Minus VR by 8 you will get. Okay. In that way, next bit you make all the bits 0. You make all the bits 0 and D2 equal to VR you make 1. Then what you will get, same procedure you follow. VR by minus VR by 4 you will get. And for MSB minus VR by 2 you will get. Okay. Now, one bit at a time, right? One bit at a time we are taking. Now superposition theory, you combine all these. So what you get? The output is minus VR by 16 minus VR by 8 minus VR by 4 minus VR by 2. All you combine. 4 bits are there, right? Now I will write this somehow like this. Minus VR I will take common. Okay, this is due to LSB, right? So I will write D naught by 16, generalized expression I am writing, D1 by 8 plus D2 by 4 plus D3 by 2. Okay, now here, where is that? See here, this is the output expression actually. The output expression V naught equal to minus VR. For that one, but for this one I'm telling minus VR into this one. Okay, so here what is D naught, D1, D2? Based on if the bit is 0 or 1, based on that you will give 0 or 1. If you see here in the given circuit, if you see here, what are connected to ground and what are connected to VR? Here VR is 1.6. This VR is 1.6. D naught is 1 they have given since it is connected to 1.6, and D1 is connected to ground, that means 0, and D2 is connected to 1.61 and D3 is connected to ground 0. That means in this you can directly replace. So what is V naught? Minus into VR is 1.6 volts. D naught is connected to 1, we have seen, right? 1, D naught is 1 by 16 plus D1 is connected to ground 0 by 8 plus D2 is connected to 1 by 4 plus D3 is connected to 0 by 2. So minus 1.6, 1 by 16 plus 1 by 4, how much? 5 by 16. So minus 0.5 volts is the output. Is that okay? Negative sign is due to inverting amplifier. Have you understood? You just later you can try. Okay. So if there are 3 bits, then in this what you will get? If there are 3 bits, I will directly write, if there are 3 bits minus VR into, always you see here the MSB is divided by 2. After that they will by 4, by 8, by 16, like that it will become. So 3 bits are there, D2, D1 and D0. So I'm writing here MSB will be divided by 2. The next one will become divided by 4. The next one will divided by 8. This is for 3 bits. Suppose if there are 5 bits, D4, D3, D2, D1, D0. Don't get confused, okay? 5 bits are there. Then the MSB, that is nearer to the op amp, that will be divided by 2. The next one, D3 divided by 4. The next one, D2 divided by 8. The next one, D1 divided by 16. The next one, D0 divided by 32. You can try later. You can take that kind of circuit and try. Okay. In some circuits, how they will give this only, in some textbooks, this only they will modify and they will give common something like this. 32 they will take common minus VR by 32. Okay. Then what you'll get, 32 16 dr d4 plus 8 d3 plus 2 d2, sorry, 16 8 4 2 d1 plus d0. Okay na? Sometimes they will write like this minus VR by, in terms of n, if it is n bit DAC, 2 power n into 2 power n minus 1 dn minus 1 plus 2 power n minus 2 dn minus 2 plus 2 power n minus 1 dn minus 3 plus so on, like that they'll write 2 power 0 into d0, something like this they'll write. Okay, different text, but that is the concept. Oh, I think we have spent enough time on this. We'll move on to the next question. Hope you don't have any doubts. Fine, we'll move on to the next. Later you can try. You can go to R, 2R ladder deck and you can see that. Fine. This was given in GATE 2020 for 2 marks. The question is as follows. X is a random variable. I think last time only I picked this question. Somebody asked from random variable, random process, right? So X is a random variable with uniform probability density function in the interval minus 2 comma 10. For 2x minus 6, the conditional y equal to 2x minus 6, the conditional probability is what they have given. Okay. So let me explain the question. What they have given is X is a random variable, uniform random variable. Okay, random variable with uniform probability density function in the interval minus 2 comma 10. That means, you know, right, it's PDF, probability density function is given fx of f, sorry, fx of x, that is from minus 2 to 10, uniformly distributed. PDF, last time I think I explained what is PDF and all. Now what will be the height of this? Total area should be 1, right? Area under PDF is 1 since it's uniformly distributed. So this length is how much? 12. So it should be 1 by 12. So total area should be 1. Okay, this is about PDF of X. Now what they have given, Y they have given. Y is 2x minus 6. So actually they are asking what? They are asking probability of y less than or equal to 7 given x greater than or equal to 5. This conditional probability they are asking, right? Can I write like this? Conditional probability, this I can write because, you know, P of A given B is what? P of A intersection B by P of B. I can write this P of Y less than or equal to 7 comma intersection or comma will write like this, x greater than or equal to 5 comma divided by P of Y less than or equal to 7. Okay. Now to find out P of Y less than or equal to 7, this probability, we should know the PDF of Y, we should know Fy of Y we know. Hope you understood this. If first we'll find out PDF of Y, then we can automatically get this equation. Is that okay? Sorry, we can solve the problem. Is that okay? Since we know PDF, probability density function of X, we need to find out the probability density function of Y. Okay. Now, how to find out? Hope you have studied in your random variables and the random process theory course. So how to find out? We cannot directly find out from the PDFs, other than we can find out from the cumulative distribution function, right? Cumulative distribution function, you know, right? CDF, cumulative distribution function, or sometimes they will say PDF, probability distribution function, they will say. Okay, that is defined as capital Fx of X. Okay, for a random variable X, the CDF, cumulative distribution function, is given by Fx of X equal to probability of, okay, probability of X less than or equal to X. Okay, CDF of X is what? Probability of X less than or equal to X. Okay, now if you, this is the definition, you can see from the textbook. I don't want to go further details. Now this is called CDF, cumulative distribution function. That is what, this is the definition, the probability of X less than or equal to X. That means what is the probability that the random variable, here this is the random variable, here X is some constant. What is the probability that the random variable X less than or equal to certain constant? Let us say X is some 10. What is the probability that random variable falls below 10? That is nothing but CDF, cumulative density distribution function. Now if I take derivative of this, that means Fx of X, derivative of this dfx of X by dx, then what we get is the PDF, probability density function. Earlier we have seen that X probability density function, this one. Okay, this is the relation between CDF and PDF. Derivative of CDF gives the PDF. Then how to get the this one Fx of X? How to get integration, right? Obviously, Fx of X is nothing but what? Probability of X less than or equal to X. How to get integration minus infinity to X? Integration of this gives the CDF, right? You got it right? For this, both sides you take integration, then integration of PDF gives the CDF, or probability of X less than or equal to X. Using this, I'll solve this problem. This is the basics. Now, what is given? Y equal to 2x minus 6 is given. Okay. X CDF anyway we know, PDF we know. Let us say X is this. Let us say probability of X less than or equal to X is what? Nothing but it's CDF, right? Fx of X. Okay. So Fx of X is what? Probability of X less than or equal to X. Okay. Now, what is this? From here, can I write X equal to Y plus 6 by 2? Can I write? Can I write X equal to Y plus 6 by 2? Can I write? So this I will write probability of y plus 6 by 2 less than or equal to x. Sorry, let it be like that. First I'll find fy of y I want to find out. Okay. Now I want actually fy of y I want, right? PDF of y, right? So for that I need to find out CDF. Then I'll differentiate. I'll get this one. So what is fy of y? Probability of y less than or equal to y is the definition, right? Fy of y. CDF of y. Okay. Probability of y less than or equal to y. Now what is y? You replace here y is 2x minus 6 less than by 2x minus 6 rate y, 2x minus 6 less than or equal to y. So this I'll write like this: x less than or equal to y plus 6 by 2. Is that okay? Do you agree? I want this one actually, fy of y I want. For that, first I am finding CDF of y. What is the by definition CDF of y is what? Probability of y less than or equal to y. So instead of y equal to 2x minus 6 I am replacing. Now this whatever inside is there, can I write like this? You take 6 other side and 2 other side, x less than or equal to this one. That means x less than or equal to some quantity is nothing but what? This is nothing but CDF of y plus 6 by 2. Do you agree this? Fx of x definition is what? Fx of x, some x is what? Probability of x less than or equal to x. Fx of some a is nothing but what? Probability of x less than or equal to a. Now instead of a I have y plus 6 by 2. So this is nothing but fx of y plus 6 by 2. That means fy of y is nothing but fx of y plus 6 by 2. Is it clear? It's 7 o'clock. I'll quickly finish this. Is it clear? Fine. Now fy of y equal to fx of y plus 6 by 2. I want the PDF, probability density function I want. So that is f small f y of y equal to d by dy of fy of y. Okay. So this is nothing but d by dy of y plus 6 by 2. Okay. So if I do differentiation, what I get is if I do differentiation, what I get? Uh, so 1 by 2 into f x of y plus 6 by 2. Is that okay? So its derivative is what? This one, PDF. This is CDF, derivative is PDF. And again, inside quantity y plus 2 by 2 is there. 1 by 2, it will come extra. Okay. This is our fy of y. That means what? Fx of x already we know. This one, right? Fx of x already we know. So from here fy of y is what? 1 by 2 fx of what I got? Y plus 6 by 2. Y plus 6 by 2. In signals you have seen that scaling and shifting. Okay, hope you have seen scaling and shifting. So the same thing you can do. First you scale it with 1 by 2, then shift it. Anyway you can do. Okay, and the overall it is multiplied by 1 by 2. So what you get? Okay, na? First you scale it. If you scale it, these limits will become from -4 to 20. If you shift left shift, if you apply -6, okay, left shift if you apply -6, signals you have seen, right? First time scaling. Now if I scale, what it will become? This PDF will become -4 to 20. Okay, and after that I need to shift it. +6 means left shift. If I shift left shift, what will happen? It will become left shift 6 units, -10 to -10 to 14, and this amplitude is multiplied by 1 by 2. Already 1 by 12 is there, so 1 by 24. So this is Fy of y. Just signals that operation applied. Okay, -10 to 24, 1 by 24. If you see the area under this curve is 1 or not, you see this length is 14 minus of -10, 24, and this is 1 by 24. Area is 1. Perfectly fine. Fy of y. So we have fx of x, we have fy of y. Now what I need to find out? This one I need to find out, right? This one I need to find out. What is that? Probability of y less than or equal to 7, x greater than or equal to 5. Okay, probability of y less than or equal to 7, comma x greater than or equal to 5 by probability of x greater than or equal to 5. Sorry, here x greater than or equal to 5. Okay, this can I write like this? This one. Now what is x greater than or equal to 5 means what? Probability of x greater than equal to 5. What is x? X is from here anything, any way you can do. X greater than or equal to 5 or y less than or equal to, any way you can do. So probability of x greater than or equal to 5 means x is what? From here y plus 6 by 2. Same thing I am writing. Probability of y plus 6 by 2 greater than or equal to 5. So probability of 10 minus 6 y greater than or equal to 4. Okay, that means probability of x greater than or equal to 5 is nothing but probability of y greater than or equal to 4. X greater than or equal to 5 means probability of y greater than or equal to 4. So now what I can do? So numerator is was y greater than y less than or equal to 7. This one I am writing here. Numerator is probability of y less than or equal to 7 and x, sorry, y greater than or equal to 4. Y greater than or equal to 4 by denominator is y greater than or equal to 4. So numerator I can write like this, right? 4 less than or equal to y less than or equal to 7 and probability of y greater than or equal to 4, right? So from here the probability is nothing but the area, right? You know the probability is nothing but area. That means what? 4 to 7 fy of y dy. Area under this 4 to 7 fy of y by y greater than 4 means 0 to infinity fy of y by dy. What is the area here? 4 to 7. 4 to 7. Here somewhere 4, here somewhere 7. 4 to 7 is what? 3 by 24. And what about denominator? Probability of y greater than or equal to 4. Somewhere here 4, right? This area is what? 4 to 7 is this one. And 4 greater than this one, right? That means 4 to 14 this one. 10 by 24. So 3 by 10. So zero point 0.3 is the answer. Hope you have understood this. Okay. So what we are doing, we are finding out we need to find out this PDF of y. For that, we are finding the CDF of y. From that, we are doing derivative. Then we got the CDF. Then we found it. Okay. And if you have any doubts, you can ask me, or else please join the other class.